So this is version A of the Thanksgiving algebra test. I'm going to go ahead and do these problems. Version B, I'm not going to go through the problems. I'm going to post the answers. If you look at these problems, this should suffice for you to figure out how to do version B. If you still need help on version B, of course, you can always email me or text me or call me. And by leaving the onus on you guys, I'm saving myself from doing extra work that you're not even going to use. Okay? So at the beginning, let me go ahead and show you the answers to version B. Version B, the answers are here. You could go ahead and pause the video if you'd like. Okay? Alright. Version A. Versión A. Empezamos ya. Okay, solve for y. That means to isolate y, get y by itself. Okay? In order to do this, we need to use inverse operations. If I think about what's happening to y, first, we're taking our y and we're multiplying by 1/5. Then we are subtracting 2. If I want to do the inverse, okay, to reverse that process, I'm going to first start with the inverse of subtracting 2, which is adding 2. And then I'm going to do the inverse of multiplying by 1/5, which is dividing by 1/5, or better yet, multiplying by the reciprocal, 5/1. So that's the SADMEP. You see how we're doing the subtraction first, and then we're doing the multiplying and dividing, and there's no exponents in this problem. So we're doing this first, and that we're doing the reverse order of operations. So what do I do first? We add 2. And just on a different level, why do we add 2? Well, if we do it to one side, we must do it to the other side, but because we had subtracting 2 at the end, we have to go backwards and now add 2 at the beginning. If we do that, we have x plus 2 equals 1/5 y. Negative 2 and positive 2 cancel each other out. Now the only thing left that happened to y is that it got multiplied by 1/5. To inverse that, I multiply by 5/1, or just 5. Multiply by 5. But I need to multiply 5 to the entire side, not just to the x, but to the whole thing. So I don't forget. If I don't put the parentheses, mom calls me for dinner, I leave, I come back, and I forget that that 5 gets applied to the 2 as well, so you have to make sure you put the parentheses. Why did I multiply 1/5 times 5? Because 1/5 times 5, or 1/5 of 5, or 5 divided by 5, is 1. So that just cancels out in a sense because it's 1. 1 times y is just y, and then I get 5x plus 10. Okay? If you didn't realize that the inverse of multiplying by 1/5 is multiplying by 5/1, if you thought another way to say it is dividing, since we multiply by 1/5, you could divide by 1/5, then you would have done this. Start from here, okay? Here's version B, or version 2. Another way you could have done it from here. Some of you guys might have, like Lourdes, I saw you do that. You divide by 1/5 on both sides. That's fine. 1/5 divided by 1/5 equals y. But you can't leave it like that. X plus 2 divided by 1/5. We're going to go ahead and copy. Change that division into multiplication. Copy, change, flip. Flip the 1/5 to 5/1. And then you would still distribute and get 5x plus 10. Okay? So y equals 5x plus 10 is number 1. Let's look at this one. What happened to the y? Well, first we took the y according to PEMDAS. Wait, oops, shoot, sorry. PEMDAS. We first have to do the parentheses. What's in the parentheses is you have, these are parentheses, you understand that? So we have to add 3. Next step, we have to do any exponents. The square root is an exponent, you know. This is the same thing as y plus 3 to the 1/2 power, because 1/2 power is square root. So the next thing is exponent, right? So the square root is the next thing. Okay, and then we have this subtracting 2 business here. Okay, it's really adding 2 to y. Anyway, so we have that. Okay, so to do the reverse order of operations, we're going to go SADMEP, right? SADMEP. If we go backwards, it's going to be Okay, doing the subtract, remember? So since we did this was the parentheses, this was the exponent, and then we did the, okay, now the reverse order is going to be the subtracting, undoing the subtracting first by doing the adding. We're going to undo the exponent, and then we're going to undo the parentheses. So it's going to go the SADMAP order, the opposite or reverse order. So what's the inverse of subtracting by 2? We're going to add by 2. What's the inverse of square rooting? It's squaring both sides. What's the inverse of adding 3? Subtracting 3. Okay, so that's my plan. As I follow my plans, I have to kind of readjust. So let's see what happens. Okay, first, I want to get y by itself. Miss Han, I just confused you guys. Because you know how they're subtracting 2? That didn't happen to the y, did it? It happened to the x. So we don't really care about you. Because I'm trying to get y by itself, not x by itself. I'm sorry. So we're going to cross that out. Okay, what happened to the y? We had added 3 and then we square rooted. So whatever happened to the y, if we want to unwrap the y, we're just going to start with taking care of the square root, which is to square both sides. Okay? I'm going to copy that, take that part out of the video. So the reason we don't deal with that part is because that's not happening to the y, it's happening to the x. Alright, so we want to get y by itself. The problem with the y is it's been added by 3, 3 got added to it, and then it got square rooted. To undo that, we want to square the square root and subtract what got added. So let's first square both sides. So I'm going to take this side and square it. Take this side, the entire side, and square it. Do we square only the 2? No. Do we square only the x? No, we square the whole quantity. Does that mean I could just distribute the square root? No, I can't just distribute the square root, because this means x minus 2 times x minus 2. And that does not mean x squared minus 4. Okay, that does not mean that. Okay, because I have to do x squared minus 2x plus 4. So make sure you do not distribute that exponent. Okay, if I square the square root, that undoes the square root undoes each other, so I just have y plus 3 without the square root, and I have x minus 2 squared. Okay, now the only other thing that's bothering the y is that it originally had 3 added to it, so lastly I'm going to subtract 3 from it. Both sides though. Okay, so now this cancels. I have y equals x minus 2 squared minus 3. And I would have actually allowed you to leave that, because the whole point is y is by itself. But you can continue, if you like, and expand that. X minus 2 squared is x squared minus 2x, and then another minus 2x, plus 4. And then we have the minus 3, right? And so then we have 4 minus 3 is 1, so x squared minus 4x plus 1. Okay, there we go. And can I factor that? No, I can't, so I'm going to leave it. All right. Apologize for that little mix up there. All right. This is the same thing where, okay, the order of operations, it helps us, but actually planning out the whole thing ahead of time is not always so useful, because we're constantly readjusting. Okay, so big picture, what happened to the y at this point? We had y on the top and the bottom. I'm going to start with my parentheses always. So in order to get rid of this fractional situation, I'm going to multiply by y minus 1 to both sides. That way, y minus 1 divided by y minus 1 is 1. So now I have, y minus 1 times x equals y plus 1. Why is that better than what I originally had? Now I don't have any y's in the denominator. It's easier to work with. But I do have y's here and here. I want them all to one side. So I'm going to move them all. I'm going to try to move them all over to this side. Okay? I'm going to try to move this over here. But before I do that, let me always kind of clean up my mess and simplify what I have here. So in order to clean up, let's clean up the mess. before I do anything else, let me clean up first. Like before leaving the house, make sure you clean up. So I'm going to distribute that. xy minus x equals y plus 1. Then I'm going to isolate the y's, or isolate the y's, or get all the y's on one side. Well, I have a y here and I have a y here. So why don't I go ahead, since I want to move everything here, which was my arbitrary choice, let me subtract y on both sides. Can I combine those? Are those like terms? They are not. No, so I can't simplify. Just xy minus y. There's still the minus x here. This cancels out and equals 1. Do I need this over here? No, you have no business being here. You're not even a y, so I'm going to move you to the other side. So xy minus y equals x plus 1, or 1 plus x, same thing. Now I've isolated my y, right? I'm good. I have, well, kind of. I only have y's on, all the y's that I have are on this side. So all my y's are on the left, but is it only y's here on the left? No. So I still want to only have a y, and I want to get rid of anything that's an x. But if I try to divide x over here, that's only good, that won't cancel out because I have a couch block here. In other words, I can't just, you know, if I try to divide by x, can I just cancel that out? No, that's a red flag because there's no x here. I can't do that. So what can I do? Well, look, there's a term here with a y and a y. I'm going to factor out the y. If I factor out the y, from here, what's left? An x. If I factor out the y from here, that y goes away, so we have minus 1. You see that? I factored out the y in order to help me isolate. Now y is by itself. So I don't need this guy anymore over here, so I'm going to divide on both sides. Okay? That's 1. So 1y, which is just y, and now I have x plus 1 divided by x minus 1. A lot of you guys just memorize this from the answer key and you just put that there, and I did not give you credit if you did not show the logical connection from here to here. Otherwise, there's no point in just writing down an answer. Okay, so y equals x plus 1 divided by x minus 1. Better if you have the parentheses. If you said x plus 1 with a side slash x minus 1, I would mark that wrong, because according to PEMDAS, you add first, divide first, or subtract first. You divide first. So that, if you say that, what you're really saying is x plus first 1 over x minus 1. Is that what you meant? No. Then say what you mean and mean what you say. If you do a sideways slash, which I don't recommend, then por lo menos, at least you need to give me these parentheses. Okay? Alright, oh shoot. I just realized I did this entire problem without switching the x and the y. So, oh no, I didn't have to, because it says solve for y. Phew, I'm off the hook. Okay, this time the directions are different. It's not just solve for y, it's find the inverse. So to find the inverse, I have to first switch the x's and the y's, right? So let's do that. Instead of y, I'm going to have x equals 1 over 2 plus y. Okay. So my first problem is that y is in the denominator. It's not going to help me to have y down there. It's too complex for me. So I'm always going to do that. I'm going to multiply by 2 plus y to 2 plus y. 2 plus y divided by 2 plus y is 1. So what's left over here? 1 times 1, which is 1. What's left over here? I have 2 plus y times x. I want y by itself. Now here's where I can, now that I've simplified, cleaned stuff up a little bit, I can think about what happened to the y. First, according to the parentheses, y got added to, 2 got added to it, and then it got multiplied, right, by x, right? Well, if I want to go reverse, I'm going to first x by dividing by x, right? And then I'm going to undo adding 2 by subtracting 2. That's my reverse order. So let's divide by x. Let's undo that multiplication by x by dividing that x. The nice thing about that is that now y is more by itself, one step closer to being by itself. Now who's bothering the x? The 2. How do we get rid of that? By subtracting. So y is going to be 1 over x minus 2. And if you left it like that, I gave you credit. But a lot of times we like to make it look much nicer. So what we can do is get a common denominator. If I want to have an x, if I want to combine these, I need to have x as a denominator. I can multiply by x over x that way, which is just 1, so that doesn't really change anything. So 1 over x minus 2x over x. Now that we have a common denominator, so it's 1 minus 2x. Okay? Or you can say negative 2x and positive 1, either way. Okay? So I can say, or 1 minus 2x over x. Okay, those are all correct. Alright, number 5, still finding the inverse. If I switch the x and the y, I'm going to have x equals 2 times y minus 1 plus 3. Okay? So if you think about it, on my side I'm going to make a note. What happened to the y? First, you have to subtract 1. Then you have to do the exponent, which is a square root. Then you have to multiply by 2. And then you have to, lastly, PEMDAS is the addition, so you have to add 3. I'm going to go in reverse order. First, I'm going to undo the adding of 3 by subtracting. Then I'm going to divide by 2. And then I'm going to do the opposite of, or reverse of square rooting, which is squaring. And then I'm going to add 1. Okay, let's see if that works. You know, it doesn't always work for us the best, but let's see. So I want to subtract by 3. So if I subtract 3 on both sides, excuse me, I have x minus 3 equals 2 times square root of y minus 1. The 3 is away, y is a little bit more by itself. Excuse me. But y is still bothered by the 1 and the 2. Which one do we get rid of first? The 2, right? So if I get rid of divide, so I did that. Now I want to divide by 2 on both sides. 2 divided by 2 is 1. So now I have the square root of y minus 1 equals x minus 3 over 2. At this point, a lot of people got here and made a serious mistake. What mistake is not listening to Ms. Han and putting parentheses here. Whenever you see a fractional expression, make sure you understand that this is x minus 3 first and then divided by 2. Because what's going to happen here is that, how do I undo the next step? Y is subtracted by 1 and then square rooted. So the reverse order is first undo the square rooting by squaring both sides. The entire both side. So let me square this side. And square just the top? No, square the entire side. If I square the square root, I'm going to get the squaring of the square root undoes each other, so I'm just going to have y minus 1. Oh, by the way, that. Okay, so let me, in between each step though, I need to clean stuff up and simplify as much as possible. What is this? If you square a rational expression, you square the numerator and square the denominator. So I'm going to have x minus 3 squared over 2? No, over 2 squared, which is 4. Okay, now I have this. The last thing I do, y is not alone because it got subtracted by 1. So to undo that, we add 1 to both sides. Okay, I'm going to go ahead and take this, migrate it over to my extra space here. So we have x minus 3 squared over 4 plus 1 equals y. Right, because these cancel out. So if you stop there, I went ahead and gave you the score because there's nothing wrong with that. You isolated y. What a lot of people said, though, which was problematic for me, a lot of you guys said x squared minus 3 over 4 plus 1. And I know that if you did this, this is definitely and entirely wrong. And that tells me that before you squared it, before you divided, or no, a lot of people had this. You basically squared it first before you divided by 2. Or I don't know, you did something in the wrong order, and so basically this is wrong. Okay? If you want, you can go further. If you want a common denominator, we can multiply by 4 over 4. Okay? So x minus 3 squared over 4 plus 4 over 4, because that's the same thing as 1, right? And now we could combine that. X minus 3 squared plus 4 all over equals y. So that's a valid answer. You can say this one or say this one. And you could even go further and say, hey, x minus 3 squared is x squared minus 6x plus 9. If you don't believe me, go ahead and expand it. Plus that 4 all over 4 equals y. And so you can simplify that by saying that is x squared minus 6x plus 13 over 4. And if you did that, props to you. Okay? You could have said x squared minus 6x plus 13 over 4. Okay? That's an expression on the top there. Okay? Okay, finding the inverse, let's do this problem here. Hopefully this will all fit. First thing is we switch the x and the y, so y equals x cubed plus 1. Alright, what happened to the y? First it got cubed, and then it got added by 1. So if we're going to do the reverse order, first we're going to subtract 1, and then we're going to cubed root. Good girl! 닫으세요. So I'm going to subtract 1 on both sides. X minus 1 equals x cubed. Now I want to get y by itself. It's a little bit more by itself. That pesky 1 went away. But now we need to cube root the cube, because that's the inverse of cubing. And so now the cubed root of y cubed is y, of course. And now I have the cubed root of x minus 1. And x minus 1 is not a perfect cube, so I cannot take it out. And so there's my answer. Or I can say another way to write that is x minus 1 to the 1/3. That means cubed root. Okay? Those are your answers. Either one suffice. I don't know if anybody did that fancy thing here. Okay? Getting down to the last two problems. This is a composition. So there's for y, finding the inverse. And then there's doing f of g of x and g of f of x. Okay, so now, what I would do is first rewrite this expression. And I'm going to just take start inside out. We're doing f of what? F of g of x. Well, what's g of x? It's this, 3x. So in other words, f of g of x is f of 3x. Well, how do we f the 3x? How do you f a 3x? Well, what does f do? F does 2x squared plus 5x. So 2 of whatever is in the baby, we're going to do 2 times that baby squared plus 5 times the baby. But what is the baby? The baby is, so f is represented by 2 times something squared plus 5 times something, right? Well, what's the something? It's no longer plain old x, it's 3x. So I'm going to insert the 3x here and here. Which means, what do I do first? Remember, PEMDAS, parentheses first. Well, nothing in the parentheses can simplify. Exponents next. So I'm going to distribute that exponent. 3 squared is 9, x squared is x squared. Now I'm going to multiply. So 2 times 9 is 18, x squared, not x to the fourth, because these are just multiplying, plus 15x, and there's your answer. If you were fancy and you wanted to factor out a 3x so that you're left with a 6x plus 5, there's nothing wrong with that either. Those are both sufficient and correct and wonderful. Okay, so do not, if you did this, if you said this is f of x, I said that's wrong, because that is not f of x. F of x is 2x squared plus 5x. This is f of g of x. Gotta be precise, math, and math precision is important. We mean what we say and we say what we mean. Math teaches us a lot of important things about life. Okay, g of f of x, g of f of x, again, you see how I'm very clear with my notation? Is the same thing as g. So the g of f of x, well, what is f of x? F of x is 2x squared plus 5x. Do you see how this can be substituted by this, can be substituted by this? All those are equivalent. See how math is logical? 2x squared plus 5x. Well, I'm going to g it. How do you g something? Well, when you g something, you take that something and you multiply it by 3. So I'm going to do 3 times the baby. Well, who's the baby who's the baby of g? Before it was x, but now g's baby is 2x squared plus 5x. So I'm going to do that times 3, which means I distribute that 3, so I have 6x squared plus 15x. And that's correct. If you wanted to factor out the 3x and say that's 2x plus 5, that is also correct. Okay, that is also correct. So g of f of x, not just g of x. G of f of x is 6x squared plus 15x. All right? Let me see if there's anything really different on the period version B that I should go over. I'll make another video for them. All right, let's stop there.